Now let's see how we can find the most repeated character in a string. This is kind of similar to the problem in the last video, but it requires a bit more work. We need to keep track of how many times we have seen each character. So instead of a hash set, we need a hash table. So let's add a new method here, public static. We want to return a character and call our method getMax occurring char. And here we give it a string. So let's declare a hash table. In Java, we have the map interface that maps a key to a value. Here, our keys are characters and our values are integers. We call this hash table frequencies and set it to a new hash map. Now we need to iterate over our input string. So for each character in str to char array, if our hash table doesn't have this character, we should add it with a frequency of 1. Otherwise, we should increase its frequency. So if frequencies contains key of the current character, we should call frequencies.replace. We want to replace the value of this key with, first we get the current value using the get method, and then add 1 to it. So this is how we increase the frequency. Otherwise, if we don't have this key, we're going to call frequencies.put. We put a new key value pair. The key is character and the value is 1. Now, this implementation is perfectly fine, but I want to show you an alternative implementation. Let's say the interviewer challenges you and say, we don't have access to a hash table. What can we do? Well, we can use an integer array to store these frequencies. So let's say our input array only contains ASCII characters. If you're not familiar with ASCII, it's short for American Standard Code for Information Interchange. It's basically a table that maps various characters to their standard numeric values in computers. So if you search for ASCII table, you can see various websites having this table. So in this table, we have various characters and their numeric value. There are a total of 256 entries in this table. So instead of this hash table, we can use an integer array. Let's call it frequencies and set it to a new int array of 256. Now, someone looking at this code may wonder, what does this number represent? This is what we call a magic number, a number that pops up out of nowhere. So to make this code more readable and more clear, we extract this magic number into a separate variable. Let's call that ASCII size and set it to 256. Now we prefix this with final, and that will convert this variable into a constant. So we cannot change the value of this constant throughout this program, okay? And this is the reason I have used uppercase letters here, because that's the convention we use for naming constants. Now, instead of 256 here, we use ASCII size. So it's clear that this integer array represents our ASCII table. Now, just like before, we iterate over our input array. So for each character in this array, we update the frequency of this character in our frequencies array. So we write frequencies of character plus plus. What does this mean? Well, let's say the current character is A. If we write frequencies of A, let's say we set it to 5, the Java runtime will first convert this character into its numeric representation. A lowercase a, I think it's 61. So this is equivalent to writing frequencies of 61 equals 5. Now, initially, when we create this integer array, all the items are initialized to 0. So in this loop, we simply increment the current frequency. Unlike hash tables, we don't have to check for the existence of a particular key. So our implementation is simpler, okay? Now, after we build the frequencies table, we need to find the item with the largest frequency. So we iterate over the frequencies array. Here we use a regular for loop. So for I, we set it to 0 as long as it's less than frequencies.length. We increment it. Now here we need to declare a variable called max. Initially, we set it to 0. And as we're iterating over this array, if we find an item with a larger value, we'll update the max. So if frequencies of I is greater than max, then we set max to frequencies of I. So with this, we can find the largest value in this frequencies array. But we want to return the character with that frequency. So we should declare another variable. Let's call it result. Initially, we set it to a blank character. Now, as part of this if statement, when we find a larger value, we should also update the result. So we set the result to the character that represents the current index. So I is an integer. We should convert this to a character. Okay? Now, finally, at the end, we should return the result. So this is the final implementation. Now let's test it. So back in the main class, let's call string utils.getMax occurring char. Once I give a pass, trees are beautiful. Beautiful. We get the result and store it over here, and then print it on the console. So E is the character with the most repetitions in the string. What if we pass an empty string? We get the blank character. That is the character with a single white space. And that's not quite right here because our input string doesn't have any characters. So we cannot say a white space is the most repeated character here. So if the input string is empty, we should throw an exception. We should tell, hey, this string doesn't have any characters, so we cannot count them. So in this method, we check to see if string is empty. We throw a new illegal argument exception. Now, what about null? Let's test that as well. We get a null pointer exception. Again, if we pass null here, our method should throw an illegal argument exception because this is not a valid input that this algorithm can work on. So we check to see if string is null or it's empty, then we throw an exception.